Okay, we'll look at some of the homework problems in section 8.5. And we'll start with problem number 1. The graph of y is equal to 3x is given in the following figure. Sketch the graphs for each of the following on the same figure. So you can see y is equal to 3x is already given in this graph. So we got y is equal to 3x plus 4 and y is equal to 3x minus 8. Okay, so here we're going to graph y is equal to 3x minus 8. Plus 4. You can use a table of values to graph this particular linear equation. In other words, you just assign, and you only need 2 points to do this. You can just assign x values here and then determine what those y values are. So for y equals 3x plus 4, I'm going to let x be 0 because that's a convenient point to use. And I'll let y equal 2. Now for x is equal to 0, we'll just replace the x with 0. So you have 3 times 0, which is 0, plus 4 will give you 4. So when x is 0, y is 4. So one ordered pair for that linear equation will be 0, 4. Now for x equal 2, replace the x with 2. So now you have 3 times 2, which is 6. 6 plus 4 is 10. Okay, so one ordered pair will be 2, 10. And I'll plot those 2 points on the coordinate plane. So here for 0, 4, I stay at 0, but I'm going to go up 4 and draw the point. And then for 2, 10, we go to the right 2 and up to 10, which is up here. Now what I'm going to do here is connect those 2 points. And this red line represents the graph of the equation y is equal to 3x plus 4. Okay. All right, the next one was y is equal to 3x minus 8. Okay, and I'll put the xy table over here. Okay, let's use some points. Well, we can use 0 because that's a convenient number to use, and also I'll use 2 as well. Okay, now for x is equal to 0, we'll replace the x with 0. So 3 times 0 is 0. 0 minus 8, that's negative 8. So one ordered pair for this line, for this graph of that linear equation, will be 0, negative 8. And then for x equals 2, 3 times 2 is 6. 6 minus 8 will be negative 2. So 2, negative 2 is going to be another point that will be on the line y is equal to 3x minus 8. Now we can plot those 2 points here. 0, negative 8, you stay at 0, but you're going to go down 8 and draw the point. And then 2, negative 2 will be to the right 2 and down 2. That's going to be here. I connect those 2 points. And this line in purple is the graph of the linear equation y is equal to 3x minus 8. Okay, now you're to choose the correct answer below. So by looking at this, it will have to be, in this case here, looking at it, you'll see that those lines are parallel. That means that those lines do not intersect at a single point. So here, it'll be answer C. Okay. All right, problem number 2 is graphing the equation by plotting points. Y is equal to negative 2x plus 10. Y is equal to negative 2x plus 10. Now I'll just create an XY table. And I only need 2 points to graph this. Only 2 points. So let's start with 0. We'll let x equal 0 here. So negative 2 times 0 is 0. Plus 10 will be 10. Okay, I'm going to choose 4 as an x value. Okay, so if I let x equal 4, negative 2 times 4 will be negative 8. Negative 8 plus 10 is -2. And actually, I need 2 points. Now, some textbooks say that you might need a third point as a check to see if that point will lie on the line. But 2 is enough here because it only takes 2 points to make up a line. So 0, 10 will stay at 0, will go up to 10 on the y-axis. And then for 4, -2 will be to the right 4 and down 2. And draw the point. And then we'll connect those 2 points. And you'll have the graph of that linear equation, y is equal to -2x plus 10. Okay, so that's what the graph will look like. Now, of course, on the MyLabs Plus system, you'll have to select the tool down here at the bottom, where you have to find out the line tool, and then it's going to be a solid line, and then you have to maneuver up to 10 on the y-axis, and then maneuver to the right 4 and down 2 to come up with the other point, and then get that line. Problem number 3. Write the following equation in slope-intercept form and identify the slope and y-intercept. This equation is x plus y is equal to 12. I'm going to write this off to the side so that you're going to see how I'm going to solve for y. Because to get the equation in slope-intercept form, which is, of course, y is equal to mx plus b, you must get the y by itself. Meaning you need to move some terms over to the opposite side. Like this x needs to be moved over to the opposite side by subtracting x on both sides. So now you're going to have y is equal to -x plus 12. Now put the -x first and then the constant second. So this is your equation in slope-intercept form. Y is equal to -x plus 12. So that answers this question right here. The equation in slope-intercept form is y is equal to, and then you'll just type in -x plus 12 as your answer. Now, if you recall, the slope, when it's written in slope-intercept form, is always the coefficient of x, or the number that's in front of the x. In this case, this represents an understood 1 in front of it. So here that slope is -1. So to answer that question, the slope of the line is -1. And of course, the b represents your y-intercept. That's the number that's added to or subtracted from your x term. So here, that 12 represents your y-intercept. So the y-intercept of that line is simply going to be 12. So here you have to write the equation in slope-intercept form by getting the y by itself. And then, once you do that, you can easily identify both the slope and the y-intercept. Problem number 4. Here we want to find the equation of the line containing the given pairs of points, 3, 1, and 9, 6. Okay, now here's how we're going to do this. I'm going to do this on a separate sheet of paper here. I'm going to write the order of pairs 3, 1, and 9, 6. Now in this case here, we need to first find the slope of the line that passes through those 2 points. And that slope formula, if you recall, is m is equal to y2 minus y1 divided by x2 minus x1. So in this case here, that first point is 3, 1, meaning x1 will be 3, y1 will be 1. The second point is 9, 6, so x2 will be 9, y2 will be 6. And then we use our slope formula. y2 minus y1 means 6 minus 1. y2 minus y1, 6 minus 1. Divided by x2 minus x1, x2 minus x1, 9 minus 3. 6 minus 1 will be 5, divided by 9 minus 3, that's 6. And this is going to be in simplest form, so it's already in simplest form. The slope is 5, 6. So the slope of that line passing through those 2 points would be 5, 6. Now the next thing we need is the y-intercept. Okay, slope-intercept form is y is equal to mx plus b. The slope is 5, 6. I'm going to use, let's say, the first point, 3, 1. Which means x is 3 and y is 1. So I'm going to substitute the x, the m, and the y in this equation to find out what b is. So here, y is going to be 1, so that's going to be 1 is equal to m, which is your slope, that's 5, 6, times x. In this case, I'm letting x be 3, plus b. Then I'm going to simplify here. 1 is equal to, now, if I divide 6 into 3, I'm going to have a 2 down here in the bottom, so it's going to be 5 halves. Okay. Now you could do 5, 6 times 3 over 1, that would give you 15 over 6, but 15 over 6 would reduce to 5 halves plus b. Now I need to subtract 5 halves from 1 to get b by itself. Now that 1 whole is like 2 over 2. Okay. Because the denominator here is 2, so if I convert 1 whole equaling to how many halves, there are 2 halves in a whole, so that's 2 over 2 minus 5 over 2, which would give me negative 3 over 2. So negative 3 halves would be the y-intercept. Okay. Now I have my y-intercept, I have my slope, so my equation is just going to be, in terms of x and y, would be y is equal to the slope, which is 5, 6, x. The y-intercept is negative 3 halves, so I'll just say minus 3 halves. Now this right here represents the equation of the line passing through the 2 points 3, 1 and 9, 6. Okay. So on here, I'll just type in and make sure you use your fraction bars that are on the template. 5, 6x minus 3 halves. Okay. On to problem number 5. Here we want to find the equation of the line that fits the description. It passes through the point 3, 2 and is perpendicular to the y-axis. What I'm going to do is draw a coordinate plane so we can get an illustration of what this will look like. All right, it passes through the point 3, 2. So you go to the right 3 and up 2. So here's the point. It's perpendicular to the y-axis. So here's the y-axis right here. If it's going to be perpendicular, that means it must be this line right here. Because that's the point 3, 2. If it's perpendicular to the y-axis, then that means it has to be this line that goes through the point 3, 2. It looks like this. And it's a horizontal line. And the horizontal line has the equation y is equal to some number. And in this case, y is going to be equal to whatever that y-coordinate is. In this case, the y-coordinate in 3, 2 is 2. Okay, so here, the equation on the line will have to be the equation y is equal to 2. Okay, because it's a horizontal line, so it has to be y is equal to some number, and it's crossing the y-axis at 2, so it has to be y is equal to 2. Okay, problem number 6. Find the slope of the line through the pairs of points by using the slope formula. Here you got 2 points, 7, negative 7, 2, and negative 6, 9. I'll write this here. Negative 7, 2, and negative 6, 9. Okay, we always use the slope formula here. M is equal to y2 minus y1 divided by x2 minus x1. All right, so let's look at how this is going to be done here. The first point is negative 7, 2, so x1 is negative 7, y1 is 2. Second point is negative 6, 9, so x2 will be negative 6 and y2 will be 9. So now y2 minus y1, that's 9 minus 2, divided by x2 minus x1, negative 6 minus negative 7. So now 9 minus 2 is 7. The denominator is negative 6 minus a negative 7, which is the same as negative 6 plus 7, which is 1. So here you got 7 over 1, which would just be 7. So that slope of the line passing through those 2 points would be 7. Okay, problem number 7. You want to find the equation on the line that fits the description. Here you have a horizontal line that passes through negative 6 and negative 7. Negative 6, negative 7, that's your ordered pair. So in other words, it's a horizontal line. That means the equation of the horizontal line is always y is equal to something. And it's going to be equal to the y coordinate of this point, which is in this case negative 7. So the equation y is equal to negative 7 is the horizontal line passing through the point negative 6, negative 7. Okay, now if it was a vertical line, then it would be x is equal to whatever that number is. But a horizontal line is always y is equal to a constant. And finally, problem number 8. This one deals with a system of linear equations. The owner of a 4,000-gallon oil truck loads the truck with gasoline and kerosene. The profit on each gallon of gasoline is 13 cents, and on each gallon of kerosene, it is 11 cents. How many gallons of each fuel did the owner load if the profit was $510? Okay, so now we want to find out how many gallons of gasoline and how many gallons of kerosene. Okay, so to set up this system of linear equations here, we're going to let x equal the number of gallons of gasoline, and y equal the number of gallons of kerosene. Okay. Now, in the problem it says there was a 4,000-gallon oil truck, and it loads the truck with gasoline and kerosene. So that means one equation is x plus y is equal to 4,000. That's the number of gallons of gasoline plus the number of gallons of kerosene, equaling the 4,000. Okay. The profit is this: 13 cents on each gallon of gasoline, and 11 cents on each gallon of kerosene. So if I'm letting x be the number of gallons on gasoline, then that's going to be 0.13x. That's 13 cents as a decimal will be 0.13, plus number of gallons of kerosene at 11 cents profit will be 0.11x. Then that's going to equal to the total profit of $510. So as you can see right here, this right here is a system of equations that we can use. Now you can use the elimination method if you want to, or the substitution method. It will be much easier to use the substitution method with this one, because I can either get x by itself or get y by itself. What I'm going to do here is take this first equation, x plus y is equal to 4,000, and get y by itself. And I'm going to do that by subtracting x on both sides. So now you have y is equal to 4,000 minus x. And then the substitution method, And by the way, this should be not 11.11x, this should be 11y. Okay. Okay, by the way, that's a y. I don't know if y'all can see that, but okay. That's 0.13x plus 0.11y is equal to 510. I'm going to take that 4,000 minus x and substitute it for this y in this equation. So if I rewrite this, 0.13x plus 0.11y is equal to 510. Substitute the y with the 4,000 minus x, so you got 0.13x plus 0.11 times 4,000 minus x. That's equal to 510. And then we're going to simplify this, 0.13x, and we're going to multiply that by 0.11 times 4,000, which will be 440, minus 0.11 times x will be 0.11x, and that's equal to 510. Combine like terms here, 0.13x minus 0.11x will be 0.02x, plus 440 is equal to 510. And then you're going to subtract 440 on both sides, which means you're going to get 0.02x is equal to 70. And then you're going to divide both sides by 0.02 to get the x by itself. So that means 70 divided by 0.02 would be 3,500. Okay, so here x is equal to 3,500, which represents the number of gallons of gasoline. Now I need to find the number of gallons of kerosene. I have y is equal to 4,000 minus x, if you recall. So I'll use that and replace the x with 3,500. So y is equal to 4,000 minus 3,500, which means y is equal to 500. And that y is equal to 500, the y represents the number of gallons of kerosene. So that means y is equal to 500 gallons of kerosene. Okay, so now, to answer that question here, how many gallons of each fuel did the owner load if the profit was $510? There was 3,500 gallons of kerosene, because I'll let x be the number of gallons of gasoline, because I'll let x be the number of gallons of gasoline, and 500 gallons of kerosene, because I'll let y be the number of gallons of kerosene. So this is an illustration of a word problem where you have to translate this into a system of linear equations and solve. Okay, so that should assist you with some of the homework problems in section 8.5.